Okay, we're recording. Okay, so problem one, what they're asking you to do here is draw a graph. And they want you to draw a graph of a profit maximizing firm in a perfectly competitive, constant cost industry that is earning positive economic profit. And they want you to answer some questions. Well, first of all, they just want you to answer, is the market price greater than, less than, or equal to the firm's price? Now this is easy, right? Because you shouldn't know from your reading that if you're in a perfectly competitive, constant cost industry, then the firms are going to take the price from the market. So the firms are all price takers. So the price is going to be the same in the market as it is in the firm, always. Okay. Now the graph we're going to draw here looks like this right here. Let me scoot you guys down here like so. So you're going to put the market on the left and the firm on the right, and you want to draw just like it is here. And so the market is going to have a typical a downward sloping demand and your upward sloping supply curve with the price right here, right? The market price marked a PM at the market quantity marked QM. Now this graph right here represents all of the firms in the market. So it could be a lot of firms that make up this supply curve right here. And then the demand are all the consumers that are consuming whatever this market is, okay? Now, your price, you want to bring that straight across, and your price in your market graph becomes your demand curve and your average revenue and your marginal revenue curve in your firm graph. It's going to be perfectly horizontal because the price is the demand curve for the firm. Okay, so that's just a straight horizontal line, and you want to draw your average total cost curve needs to be a U-shaped curve, and you want to make sure you draw this where, if you go back to the question, where the firm is earning positive economic profit, which means that you want to make sure that you have wherever the quantity is going to be where the marginal cost curve crosses the price. That's where the firm is going to produce at Q of F. Okay. Now that point needs to be above your average total cost. That is why we say that we are earning a positive economic profit, which would be this rectangle right here. Okay. Now, they also want you to shade in your total cost, I believe. Let's see. Right. They want you to shade in the area representing total cost, which is going to be, you jump back over here, the point where the point that you're producing up to the average total cost curve, because this is saying that the average total cost is this point right here where we're producing. So the total cost is going to be the average total cost times the quantity. So this rectangle right here is going to be your total cost. So you want to draw a line straight down from the average total cost curve to the quantity, and you know where the quantity is because that's where the marginal cost curve equals price. A firm in a perfectly competitive market is always going to produce where marginal cost equals price, okay? And then you want to draw the line over from here straight over, okay? And then this is going to be your total cost. And then this area, now they're not asking you, but I'm just showing you this area right here is the total profit, okay? Because that's the difference between the price and the average total cost, and that's going to be your profit. Now, total revenue, and they're not asking you, but just so you know, total revenue is this whole box right here, okay? Price times quantity, okay? So price times quantity is going to be your total revenue, okay? I think that takes care of everything up to that point. Does anybody have any questions about regarding these two graphs? Okay. Next. Okay, so now part C, if one firm in the market were to raise its price, what will happen to that firm's total revenue? Well, it would go to zero, because the price here for the firm is perfectly elastic, which means if one firm were to raise their price above the market price, they would lose, theoretically, they would lose all of their customers, and their revenue would go to zero, okay? Okay, part D. Now suppose the market is in long run equilibrium. The government gives a lump sum subsidy to each firm producing in the industry. Indicate whether each of the following will increase, decrease, or remain the same. Okay, so the firm's quantity in the short run is not going to change at all. Why is that? Because a lump sum subsidy is only going to change your average total cost, okay? It's going to make average total cost a little bit lower, depending on the lump sum subsidy averaged out, over the quantity that's being produced. A lump sum subsidy does not change the marginal cost curve at all. So the quantity produced is going to be exactly the same, okay? Does everyone understand why that is? Lump sum subsidies only affect the average total cost. It's going to make this curve right here be lower. Okay, the cost would go down. Okay, but it would not change this point right here where the firm is producing, where price equals marginal cost. That does not change the marginal cost of producing more units. A lump sum subsidy would not change that at all, okay? Now, the next part is they're asking about the market price and quantity in the long run. Okay, in the long run, what would happen in the market if the average total cost for each of the firms were to be lower? That would mean more firms would want to come into the market because there's a lot of profit here. Firms theoretically will come into this market until there's a zero economic profit. So what that would look like, firms coming into the market would mean a shift in the overall market supply to the right. This shift represents firms entering the market because they're seeing the opportunity to make profit right here. Okay. Now, what would happen then is the price would drop, and the quantity, overall quantity, would increase until such point where, let me see if I can get this guy right here, until such point where the price was equal to the average, the average total cost, and then at that point, all of the firms in the market would be making zero economic profit, where price equals average total cost. Okay. So the answer is for the market, the price would go down and the quantity would go up. Let me just make sure yeah. Okay. So that takes care of question number one, problem one. Does anybody have any questions? Okay. Let me stick this guy right there. Okay. So that's problem one. We'll move on to problem two. Problem two. Yes?
But if the economic profit was reduced to zero, then wouldn't firms just drop out because there's no profit?
No. Whoa, okay. A good question. We said economic profit, okay? Now, what does that mean? It means that we're including in the cost opportunity cost, okay? Don't forget that. A firm can make plenty of accounting profit and make zero economic profit. Now, let me explain that. Let's say that I have a job teaching in a school, okay? And let's say I'm earning $50,000 a year, okay? And I decide that I'm going to quit my job and go and open a private tutoring business. And the first year in my tutoring business, I earn $50,000 a year. What's my economic profit that first year?
Zero.
Zero, because we have to factor in what the opportunity that I gave up. I'm no longer teaching school, right? Now, had I earned $60,000 with no more cost, let's just say that my tutoring is a cost-free business, okay, which isn't, but let's just say it is. Then I would have an economic profit of 10,000, right? But so when we say an economic profit of zero, don't forget that is calculating in opportunity cost, okay?
Oh, okay. That makes more sense now.
Yeah, and when we just talk about a accounting profit, that's not okay. That's not taking into consideration opportunity cost. Okay, but that was a very good question. Thanks for bringing that up. Okay, problem two. Let's go back and see what that one is. Okay, once again, we're looking at a market that is perfectly competitive, and this time they're telling us that it's avocados, and a typical firm is once again earning positive economic profit in the short run. So we want to draw a correctly labeled graph just for the firm where we're showing it in short run equilibrium and labeling the equilibrium market price and output PE and QE. Okay, so let's see what that's going to look like. It's going to look like this. Okay, can you see it okay? Now, without this, okay, now when you first draw it, you're only going to have one marginal cost curve, okay? This second one right here is drawn in because, let me just jump that up there, because the second part of the question is at, well, actually, let me just stop there. Now, what you want to make sure of, and I didn't say this in the last one, very, very important. And Eric, pay attention. This is important because this is going to be confusing if you don't really think about it, okay? Every time you draw these, what the graders and what I'm going to look for, and what any of the graders on the AP exam are going to look for, is did you draw the marginal cost curve through the minimum point of the average total cost curve. This is always going to be true. Why is that? Because whenever the marginal cost is higher, at the point where the marginal cost is more than the average total cost, the average total cost has to be increasing. That's just a mathematical truth, okay? Because what is the marginal cost? It's the cost of producing that next unit, okay? So if the cost of producing the next unit is higher than the overall average, it means that the average has to be increasing, right? If the cost of producing the next unit is lower than the overall average, then that's going to be pulling the average down. So the average is going to be decreasing as long as it's above marginal cost. As soon as the average cost is above marginal cost, then it is increasing. I mean, what did I just say? I just said it backwards. As soon as marginal cost is above average cost, then average cost overall has to be increasing, which is why we always have to draw the marginal cost curve through the minimum point on the average total cost curve. And when you draw these, you want to try to make that very obvious, okay? Very obvious that it's actually at the minimum. Okay, okay, guys? Does that make sense? Okay, now we have a second marginal cost curve drawn here because it's asking us, it's telling us that there is an increase in the market wage rate for labor, which is a variable factor input for a production. And we want to show on our graph that we just drew in part A, the effect of the wage increase on the marginal cost curve in the short run. Well, what's going to happen is the marginal cost for a production gets more expensive at every level of output because wages are higher, because they're having to pay their workers more. So if we think about this this level right here, QE, the cost was here, now it's up here, okay? So at every level of output, it's going to be more expensive to produce, in this case, avocados, okay? Does that make sense?
Wait.
Yeah.
So the wage, so it was a fixed input though. What would happen was that the average cost would just go up, the average total cost?
Well, the average total cost would go up if there was a lump sum subsidy or a tax. If there was a lump sum tax, just one fixed tax, right? Because if you go back and you look at what a tax would be, sorry about that. Let me jump back over here. Is if you think about fixed costs, okay, and a lump sum tax would be a fixed cost because it would be the same no matter how many units were produced, okay? And the average total cost is the average variable cost curve plus the average fixed cost, okay? So that's the difference here, all right? So if you had a lump sum tax, then this curve right here, let me grab my little blue ball here so I can show you. The average fixed cost would be, whoops, where'd it go? Oh, disappeared. I mean, it's just, let's see, order agreement. So if we had a lump sum, just a one lump sum tax, it would cause this curve right here to be higher, more expensive. The average fixed cost would go up, which would affect not the average variable cost, but it would add on to the average total cost. So this curve right here would also go up, okay? A per unit tax, a tax that was taxed only if you produced, units of whatever it is, would affect your marginal cost curve. It would shift up, okay? So a wage increase is like a per unit tax. It's like making every unit cost more because you have to use workers in order to produce more units, okay? And if you're not producing, you're not paying your workers, right? So that's why an increase in the wages would be a shift in the marginal cost curve right here, okay? Which looks like this right here, okay?
Okay.
Yeah, kind of confusing, I know. Now, the next part of this, they're telling us, so we are going to assume that the avocado producers hire workers from a perfectly competitive labor market. And we want to draw a graph of the labor supply and demand for the typical firm and label the supply curve a marginal factor cost, or MFC, and the demand curve marginal revenue product, or MRP, okay? And we want to assume that the wage rate increases from W1 to W2, and we want to show the effect of the wage increase on the graph, the labeling, blah, 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 and I will do that right now, okay? Looks like this, okay? Let me make this, let me get you guys over here so you're not quite in the way. Let me move you guys. There we go. Can you see it? There we go. Now, the important thing here is to understand that for the firm, this is the firm, okay? Whoops. This is the firm. This is their demand for labor, okay? Their supply of labor is just like the firm's price for the good. The wage rate is going to be set by the market. So it's going to be a perfectly elastic horizontal curve, okay, set by the market. So that the firms theoretically can't change the wage at all, because if they were to, like, say they were to lower the wage, then all the workers theoretically would go work for a different firm that was paying the market wage rate. Now, the problem wants us to show an increase in the wage from a W1 to W2, which would simply look like this. And what would happen is you would have to hire the number of workers now where the last worker had a marginal revenue product equal to the new higher wage. And if you remember from our last chapters, theoretically, as a firm hires more workers, their marginal product diminishes. That's why this curve is downward sloping. So if the wage is higher, the firm is going to have to hire fewer workers at a higher wage rate. Okay, so your graph is going to look just like this. Okay, so you're going to have a higher wage and fewer workers hired, and you're going to have a shift in your marginal factor, a cost a curve, a shift up, or your labor supply, and you're going to have a movement along the labor demand from here up to here. Okay, does that make sense? All right, guys, I think that's it. Yep, that's it for problem 2. Now, the thing to also realize is that the market. Let me just jump back over here. The market labor supply and demand looks a lot like the market right here. It's just going to be, a labor supply, a labor demand, with the wage rate right here coming over to something that looks like this right here. Okay. So for the firm in a perfectly competitive market, the price of the good is the firm's horizontal demand curve. The wage rate for the workers is the firm's horizontal labor supply curve. Okay? Good. All righty. Moving right along then. We're almost done. So let's see. Problem 3. Okay, now we have the John Lamb Company, which is a profit maximizing firm producing widgets, and they're in a perfectly competitive widget market. And John Lamb employs a fixed number of employees and rents a machine for a variable number of hours from a perfectly competitive market. So we want to draw side-by-side graphs of the factor market for machines and the John Lamb Company firm. Okay, now this is going to be just exactly like the labor market, only we're talking about capital in terms of machines. Okay, and so we think of labor as costing wages, and we think of capital as costing rent. That's just what we call it, rent. Okay, does that make sense? Or kind of? Is how it is. Okay, so it's going to look like this. Okay, let's get you guys down here again. So, and they wanted you to do. Let me see what we're. So this is what it basically looks like. But I'm just going to jump back over and see what we're being asked here. Okay. Okay, so if the popularity of widgets declines and the demand for widgets decreases, this means that in the market, the demand curve for widgets is going to shift to the left. Okay. What will happen to each of the following? The marginal product curve for machine hours and the marginal revenue product curve for machine hour. Now, this is tricky. Now, think about this. The marginal product is just what product a machine can produce, and that doesn't have anything to do with demand or price at all. So the marginal product, the physical product that a machine can produce in terms of the widgets, does not change at all. However, the marginal revenue product, which is marginal product times price, does. Because, now here's your graphs, you're going to have a shift to the left in your marginal revenue product curve, because if the demand curve for a widget shifts to the left, think about that, the price is going to decrease, right? If we just have a typical supply and demand curve, then a shift to the left of the demand curve is going to make the price lower, isn't it? Right? And that just makes common sense, right? If something gets less popular and fewer people want to buy it, that's going to drive the price of the thing, whatever the thing is, down, right? So now the marginal product curve, which is not even shown here, doesn't shift at all. The marginal revenue product curve, which is marginal product times a price, is going to shift because price decreases, okay? So the marginal product of the machines, the physical capital does not change just because the price of widgets decreases, okay? Does that make sense, guys? And here's your graphs, okay? So they're asking us, okay, so we explained part B. Now we want to think about this idea of either cost minimization or profit maximization. It's kind of the same, it's just like two sides of the same coin, okay? When we think of minimizing a cost, we can also think of maximizing profit. Now, this is just a simple ratio. The marginal product of labor is 28 widgets per worker per hour, per worker hour, and the wage rate is $14 an hour. The marginal product of the machine is 60 widgets per machine hour. What is the hourly rental price of the machine if we want a combination of inputs that minimize cost? What do we do here? Okay, so we look at what it is to either minimize a cost or maximize a profit. We want the ratio of the marginal product of labor over the marginal product of a capital to equal the ratio of the wage rate over the rental rate. Or we can say that the marginal product of labor over the wage rate should equal the marginal product of a capital over the rental rate, okay? Either one of these will get you to the answer, okay? And we simply plug in our numbers. We know that the marginal product of labor was 28, let me just jump, it was 28 widgets per hour, per a worker per hour, and the wage rate was $14 an hour. So I'm using this one right here. Okay, let me grab my thingy. Sorry about that, guys. Let me scoot you guys up here again. There we go. So now, whoops, let me grab the right. There we go. So we're looking at, I actually did this both ways, right? Here I'm using marginal product of labor over marginal product of capital, and we know that the wage rate was $14 an hour, and so in order to make this ratio work, the rental rate has to be $30 an hour, right? And then we can also use our marginal product of labor, whoops, hold on one second, over our wage rate should equal our marginal product of capital over our rental rate right here. So our answer is $30. Does everybody understand that? How that works? It's not that hard. Just make sure you have the ratio right. And that is your 3 problems for perfect competition. Okay, guys?
Sure.
Now, make sure, I hope you guys are have set aside time to look at the, let me jump over here, to look at these videos, because these videos right here are very, very, very helpful, okay? And you need to look at all of these. And this will help you I mean, if you look at these, this is really, I mean, these are very straightforward and very helpful, along with the book. But I actually like the videos better than the book, personally. But it's, up to you guys. Do both, but don't forget about these videos, okay? And I will send out a study guide for the quiz, hopefully by tomorrow. Let's see, tomorrow's Wednesday. Yeah, by tomorrow. I'll really try to get that out to you guys, okay?
Do you think you'll have time to do a session
for the quiz?
For the study guide?
Yes, I will. I will take. See, let me just tell you guys. Actually, I'm going to stop the. Well, actually, I'll let the recording run. I will if you guys want it, right? And if I hear you, and if you guys think it's going to be helpful, I'd be happy to. So, am I hearing that it would probably be helpful?
I mean, I use them, so.
Good. Okay. Good. Glad. I am happy because I don't know, sometimes it's just easier to sort of hear it again, and just go over it.
Yeah.
So I will work very. I've actually had the flu, to tell you guys, and so today's the first day I felt like actually doing anything. So get your flu shot. Don't ever go. I mean, that was the dumbest thing, man. I mean, the flu is horrible.
Yeah.
I don't know what's that. I mean, I felt like, yeah. So I'm better now. So I'm going to stop the recording here real quick. And